UFO conspiracies. Is Comet 3 I/ATLAS an alien spacecraft? Chapter 1. The Hidden Signal. You settle into a quiet observatory of the mind, tuning into a faint pulse drifting across the cosmic sea. Through your inner ears you hear a whisper of radio waves, vibrations below human hearing that radio telescopes capture and translate into numbers. This gentle hum feels like distant wind over mountains of data, a subtle rhythm you can almost sense in your bones. In the digital static, you notice patterns, bursts of energy that repeat with surprising regularity. Scientists use Fourier transforms to pick out these hidden frequencies, unraveling radio data into peaks and valleys. You imagine each spike as a heartbeat, a coded pulse that hints at structure within chaos, like secret Morse code from the void. Your attention drifts to an array of parabolic dishes sweeping toward Comet 3 I/ATLAS, a traveler from another system. You picture the comet's icy nucleus, a handful of rock, ice and dust hurtling through space. You know that natural comets release gas and dust that scatter sunlight. Yet you wonder if this one carries something beyond familiar chemistry. Each whisper in the spectrogram feels loaded with potential meaning. Scientists measure spectral lines to identify molecules, while Doppler shifts reveal motion toward or away from Earth. You feel a gentle thrill as you consider whether the spikes emerge from organic compounds, simple carbon chains, or perhaps from repetitive signals, unlike any you've decoded before. Beyond what your eyes see, the comet emits radio frequencies invisible to daylight vision. You dwell on the electromagnetic spectrum, where each band carries its own story. Microwaves warming cosmic dust, ultraviolet light glowing from hot gases, and radio waves whispering secrets of distant worlds. You realize that hidden color lies not in paint, but in shifts of wavelength and energy. You linger in this space of questions and possibility, feeling the weight of data lines like pulses under skin. In the hush between each signal, you sense a doorway opening toward deeper mysteries that quietly await your curiosity. Chapter 2. Spectrum of Secrets. You wander along the comet's glowing tail, as if you were tracing a river of stardust through the inky void. Soft pillars of gas swirl around you, illuminated by sunlight split through your spectrograph's prism. Each beam fans out into a ribbon of color, silent and expansive, revealing a cosmic tapestry woven from every shade of the electromagnetic spectrum. Within that ribbon, you notice the ultraviolet fringe, a violet halo beyond what your eyes can see. In that hidden glow, sharp spikes in intensity mark the fingerprints of unexpected elements, metallic iodine shimmering at one edge, and tiny silicate clusters whispering their angular bonds at another. You recall that each element absorbs and emits at specific wavelengths, a key that unlocks their chemical identity. As you chart these spectral lines, you imagine them as notes in a grand cosmic symphony. Each dip and peak corresponds to an atomic transition, electrons jumping to and from higher energy levels. Your spectrograph becomes a lantern in the dark, illuminating secrets that comets usually hide. These anomalies, rare in typical comet chemistry, hint at processes happening far from any familiar solar cradle. You pause, heart steady, and wonder whether these patterns form a coded signature. Could an intelligence have seeded this traveler with exotic elements, writing a subtle message across its tail? The idea feels both distant and intimate, like reading a letter folded into starlight. Science and speculation intertwine, urging cautious curiosity as you record every nuance. Then, almost imperceptibly, you detect a slight shift in wavelength, a silent Doppler tug, as if the comet itself were breathing, pushing against space with hidden force. That gentle acceleration suggests not only natural outgassing, but something more deliberate, like propulsion woven into the spectral glow. You release a slow breath, aware that every color holds a clue. With your data safely stored, you sense that deeper revelations await just beyond this shimmering edge. You wonder how these spectral secrets might guide you deeper into the comet's heart, where warmth and density converge. Chapter 3: Propellant of the Cosmos. You drift beside 3, I/AT/LAS, feeling the hush of space around you. The craft sails without chemical propellant, moving instead on the momentum of sunlight. Light consists of photons, each carrying momentum that nudges the sail with delicate force. Even in the emptiest reaches, these particles provide steady thrust. You notice the gentle tension of invisible waves, like a breeze of pure light guiding the vessel on its silent path. The sail unfolds like a gossamer wing, a mirror of ultra-thin polymer film, only micrometers thick. As sunlight strikes this reflective membrane, photons bounce off its surface, transferring momentum in minute bursts. This radiation pressure may seem faint, measured in millinewtons per square meter, yet over months it accumulates into significant acceleration. You imagine each burst as a heartbeat of light, pulsing against the silvery fabric and pushing the ship ever onward. Alternatively, you envision a magnetic sail unfurling fine superconducting wires into space. Solar wind, a stream of charged particles from the sun, interacts with the sail's magnetic field, creating a magnetic bubble. This induced magnetosphere deflects protons and electrons, imparting momentum to the wires and generating thrust without fuel. You feel the soft hum of plasma currents as they stream past the mesh, guiding the craft with unseen electromagnetic grace. Beyond photons and fields, a subtler tool echoes in radio waves. Engineers send pulses of radio waves to measure Doppler shifts, revealing minute changes in velocity. Each echo returns with a fingerprint of motion, frequency changes that whisper the craft's speed and direction. This telemetry precision, measured in millimeters per second, lets you adjust subtle tugs and rotations. You sense a hidden architecture of signals weaving through the void. Your mind drifts among these possibilities, each method a whisper of ingenuity and cosmic collaboration. You sense the interplay of light, fields, and signals as threads in a grand tapestry of exploration. In this quiet moment, you understand that propulsion is more than force. It is a conversation with the universe, and its next secret softly awaits, beckoning onward. Chapter 4: Whispering Waves. You cradle the tuning dial in your fingers, coaxing it to accept the faintest pictures of space. You feel electromagnetic waves brushing past your receiver. Space is never silent. It sings in radio frequencies beneath human hearing. These faint signals travel at light speed, carrying stories from distant, mysterious worlds. With gentle patience, you listen. You imagine molecular clouds drifting between stars, each molecule vibrating in its resonant chorus. When a water molecule flips its spin, it emits a photon at a precise frequency. Astronomers call these spectral lines. They map temperature and density, revealing nurseries of new stars. You trace these invisible signatures like a cosmic map, feeling guidance. You slide through frequency bands like hallways of light. Low frequencies hum with galactic hydrogen at 1420 megahertz. Higher bands crackle with solar flares and quasars. Your receiver flickers at modulated pulses, patterns hinting at cosmic processes. In each band, you catch a fleeting echo, a note in the concerto of space to be understood. You recall Nikola Tesla's vision of wireless power, towers tuned to Earth's resonances. He believed you could tap the planet's signal like a sympathetic string. Later, radar experiments quietly bounced pulses off meteors and comets, seeking their electrical secrets. You sense those pioneers in every echo, as though their dreams live on in each waveform. You tune for a ping, like a heartbeat in the cosmic dark. Comet 67P's coma sheds gas that interacts with the solar wind, carving a plasma tail that sings at low frequencies. Each echo you detect could be natural turbulence or a code, folded in the comet's wake. Scientific rigor guides your hope. You log every spike, every dip, formulating hypotheses about meaning hidden in the drift of charged particles. You feel gravity's veil drawing you inward, bending space and thought. Gravitational lensing may reveal hidden structures beyond the comet's tail, warping distant signals into arcs. Each measurement leans toward discovery, faith in nature's design. You follow subtle curvature deeper into the still unknown, sensing the next revelation waits beyond your grasp. Chapter 5. The Lensing Veil. You lie on soft grass under midnight's hush, feeling the gentle whisper of the cosmos in your breath. Your gaze turns toward the sun's edge, now sinking behind a distant ridge. There, Einstein's insight unfolds softly. Immense gravity curves the path of starlight, bending it like water around a smooth stone. You imagine ancient photons traveling for eons, detoured by that invisible force just beyond our sight. You think of Comet 3 I/ATLAS, slipping through that warped expanse, its icy nucleus glowing faintly. Through the gravitational lens, the comet's tail stretches and splays, turning into a shimmering arc of light. You envision it as a pale ribbon, luminous against the dark canvas, magnified beyond any telescope's ordinary reach. In this bending halo, even the faintest grains of dust become visible messengers from the edge of the solar system. In that warped light, you notice subtle distortions, slight arcs and smears, telltale signs of multiple images overlapping. This is the Einstein ring emerging in miniature, where photons from different paths converge. You sense how gravity acts like a lens, focusing a distant view into a soft glow. Each bright spot in that glow carries secrets about mass and energy hidden along the line of sight. You remember secret experiments, plans whispered by scientists to place detectors hundreds of astronomical units from the sun. They imagined our star's gravity as a vast telescope, peering deeper into the galaxy. A solar gravitational lens proposal envisions a probe at about 550 astronomical units, waiting for light to focus. Though unrealized, this dream still hums with human curiosity. As you breathe, you feel connected to silent architecture. You imagine dark matter filaments weaving unseen scaffolding for galaxies and comets. Rays passing near the sun hint at a vast cosmic web glimpsed only in scattered light. Your mind drifts between known and hidden, tracing shapes that might reveal nature's design. In the dim, bending halo, you rest in wonder, knowing each beam carries a question. You hold your breath for the next whisper of insight, feeling the edges of discovery press softly against your thoughts. Chapter 6. Silent Sirens. You stand beneath the velvety expanse of stars, feeling the quiet pulse of the cosmos against your skin. Tiny grains of cosmic dust drift by, each particle a messenger from distant origins. Imagine microbes nestled in rock crevices, shielded from heat and shock, carried on meteoroid fragments as they traverse solar winds. Your breath deepens as you sense the possibility that life, in its smallest form, might journey across the void. Tardigrades emerge as your silent companions in this thought journey. Researchers aboard the PHOTON M3 mission expose these water bears to extreme vacuum and solar radiation, and more than 60% survived. In cryptobiosis, they retract their limbs, drop metabolic activity to near zero, like seeds waiting for spring. You picture them drifting through cosmic voids, microscopic survivors hitching a ride on comets, unperturbed by temperature swings from hundreds of degrees to near absolute zero. Many scientists wonder if 3I/ATLAS, the interstellar visitor detected in October 2019, might harbor such living stowaways. Named for the asteroid terrestrial impact last alert system that found it, this elongated rock moves through the solar system at nearly 30 kilometers per second. You consider panspermia, the theory proposed by Svante Arrhenius in the early 20th century, which suggests life can spread between worlds on dust or debris. Beyond natural transfers, the old conspiracy whispers of intentionally seeded life. Francis Crick and Leslie Orgel once speculated about directed panspermia, imagining cosmic arcs carrying microbes to new habitats. You feel the weight of that hypothesis as you muse over the possibility that life's architects cast silent sirens into the infinite. Each tiny organism could be a message in a bottle, preserved in armor against cosmic rays and ultraviolet glare. You listen for whispers of electromagnetic enigmas, faint signals that dance at the edge of your instrument's sensitivity. SETI searches for such techno-signatures, scanning radio waves for patterns unlike any natural source. But here, between your heartbeat and the cosmic hum, you sense something unmeasured, something beckoning. It is an invitation to the next mystery, a resonance that lingers unresolved, calling you deeper into the starry unknown. Chapter 7. The Forbidden Lens. You stand beneath the silent dome of night, listening to the hush of distant frequencies. A low, steady hum drifts through your mind like a cosmic heartbeat, each pulse a whisper from antenna dish arrays tuned to invisible waves. You feel the sweep of radio astronomy reaching across light years, mapping the unseen shapes drawn by cosmic microwave echoes. Your curiosity traces the faint outlines of dark matter, that invisible scaffolding believed to cradle galaxies. Researchers speak of clusters and halos, their gravity shaping the cosmic web through gravitational lensing. It feels like filigree of shadow, delicate yet vast, sculpting starlight. Modern detectors search for wimps and machos, hoping to touch that silent framework behind the shining cosmos. In Legends of 3I/ATLAS, you glimpse a daring quest. Could exotic particles or suppressed quantum fluctuations warp local gravity? You recall experiments in underground labs where cryogenic detectors chase ghostly interactions deep beneath Earth's surface. Imagine tiny filaments of massless matter bending space like silk over a hidden form. You feel theories call, gently urging you beyond known equations. Some whisper of a coating woven from metamaterials that softly twist space-time curvature, a cloaking veil shielding mass from probing instruments. You picture a ripple on still water, light skimming its surface without revealing the stone beneath. It is where general relativity and quantum hints entwine, whispering through equations that bind matter and energy and shape a reality's hidden contours. Yet your scientist's caution flutters, anchored in falsifiability and peer review. Mainstream minds dismiss such marvels, demanding evidence carved from observation, not speculation. You remember Galileo's telescope, reframing doubt into clarity, and LIGO's delicate sensors, attuned to spacetime's ripples. These legends affirm that careful measurement can transform mystery into understanding, guiding you to hold wonder and curiosity with method. In that tension, you glimpse a faint spectral line tucked in guarded radio archives. A spike at 1420 MHz, born of hydrogen's hyperfine transition, resonates with secrets of galactic rotation and cosmic birth. You sense the file trembling at the boundary of comprehension, where fact and possibility merge in soft light. Questions about dark energy's role beckon you forward. Chapter 8: Echoes in the Void. You step into a chamber where the Breakthrough Listen archives glow on your screen. You feel the hum of countless radio telescopes, each dish tuned to capture invisible waves across vast cosmic distances. Radio waves travel like ripples on an ocean, with wavelengths measured in meters or kilometers. Here, every captured pulse holds a story waiting to unfold. As you open a file of raw voltages, you witness numbers pulsing like a universal heartbeat. Spectrograms transform those voltages into color maps of frequency versus time. In a spectrogram, brightness marks signal strength, and each horizontal line is a constant frequency. You recognize patterns where natural sources like pulsars or hydrogen clouds glow in predictable bands. You notice the cosmic background whispering across channels. The microwave background, a relic glow from the Big Bang, fills radio windows around 160 gigahertz. You also see the hydrogen line at 1.42 gigahertz, a universal marker where neutral hydrogen atoms emit energy. These signals form a gentle hum, baseline of natural noise that frames every deeper search. Your mind drifts to the wow signal, a burst detected in 1977 at 1420 megahertz. That narrowband tone lasted only 72 seconds, yet it sparked decades of wonder, debate. Scientists know that genuine extraterrestrial transmissions would need confirmation from multiple observatories. Still, the memory of that anomaly reminds you how curiosity drives skilled listeners to sift through mountains of white noise. Protocols require checks before claim of alien tech. Teams cross-reference signals, schedule follow-up observations, and apply statistical tests to rule out interference from satellites or terrestrial radar. You learn that a single spike in voltage often hides mundane sources like solar flares or distant aircraft. Yet the discipline of peer review preserves skepticism and hope, ensuring that genuine discoveries emerge from careful scrutiny. As you scroll through spectrograms, a faint flicker leaps across a narrow band. Its pattern is irregular, neither matching terrestrial chatter nor known pulsar rhythms. You pause, feeling a blend of doubt and exhilaration. Every pixel might hide a message from worlds beyond, or a glitch in the receiver. In this moment between silence and signal, you sense a call that beckons you onward. Chapter 9: Phantom Trajectories. You settle into your chair as your screen glows softly, revealing the comet's pale arc curving through space. Each point you mark becomes a gentle pulse on the display, reminding you of the delicate dance between mass and motion. You trace the path with a calm breath, feeling how gravity lures and tugs, bending the silent traveler around the sun's embrace. Observing these arcs, you sense a quiet invitation to explore the subtle forces at play, the same forces that guide planets and shape our cosmic neighborhood. As you examine the data more closely, you notice a slight divergence from pure gravitational motion. The comet's route veers a fraction of a degree, hinting at an added influence beyond Newton's pull. You recall the Yarkovsky effect, where uneven heating of a rotating body alters its path, and you consider solar radiation pressure, streams of photons imparting minuscule thrust. These real phenomena teach you how small forces accumulate over millions of kilometers, guiding dust grains and asteroids alike. You open chapters from long-forgotten journals, dusty papers by researchers once deemed too radical. They propose reflective arrays that catch sunlight like a sail, or directed energy beams boosting speed. Their theoretical trajectories overlay neatly on your observations. In those curves and kinks, you find echoes of precise calculations, proofs that gentle pressure from starlight or a focused beam can steer a vessel in the void. Plotting each adjustment, you see patterns emerge. A subtle engineered course correction here, a fine nudge of momentum there. The data align across independent models, hinting at design rather than chance. It feels as though someone has composed this celestial ballet, guiding the craft with intention through the dark. As you inspect the orbital elements, you study eccentricity and inclination, perihelion distance. You watch how slight changes can shift a path by thousands of kilometers. You notice subtle outgassing jets, temperature gradients along the surface, and albedo variations that become tangible clues to the comet's shifting momentum. You plot the final vector, a graceful arc that carries the phantom trail beyond your current map. You hold this vector gently in your mind, feeling its silent invitation. Where will it guide you next? Chapter 10. Into the Quiet Beyond. You stand at the boundary where starlight fades into emptiness beyond. Your vessel's sensors measure infrared pulses and radio waves, translating whispers of distant suns into soft hums. Each hum feels like a heartbeat, steady against the silent dark. You close your eyes briefly, grounding yourself in the rhythm of detection and the deep calm of space. Data flows across your console in ribbons of color and swirling code. Spectroscopy reveals shifts in wavelength, redshift suggesting distant drift, absorption lines revealing unseen molecules. You picture each spectral line as a fingerprint unique to hydrogen, carbon, or metals forged in ancient stars. Light carries these clues across light years, a clear message from the past for every curious mind. Beyond these figures lies a tapestry of cosmic dust and gravity's gentle pull. The object's path curves in 3 dimensions, guided by unseen forces near planets and comets. You recall gravity wells shaping galaxies, keeping stars in silent orbits. Against that vast backdrop, 3I/ATLAS feels both intimate and immense. A lone drifter in fields of dark matter. You wonder if the secret of this interstellar visitor lies not in origin, but in our readiness to perceive the extraordinary. Its composition, minerals and ices unfamiliar on Earth, reflects processes from before our solar system formed. Each grain of ice or organic molecule hints at chemical stories older than any planet here. Each insight expands your imagination and wonder. You also detect subtle patterns in electromagnetic fields, hinting at deliberate signals or structures shaped by technology. You imagine civilizations harnessing stellar engines or bending gravity for lenses. These ideas rest on physics you trust. Maxwell's equations describing fields and Einstein's view that mass warps space. Yet perhaps the most meaningful reflection lies in our hopes mirrored in every speculative design. As you drift in quiet contemplation, the near vacuum around your craft holds cosmic background radiation, relic light from the universe's dawn. Each faint photon carries memory of creation, whispering secrets in every direction. You feel the weight of time spread thin in this void, where uncertainty becomes a gift, opening doorways to questions more vast than any answer. You close your eyes once more, guided by curiosity's gentle tug toward horizons still unseen.